Hi, my name is Andrew Kelso. I'm a basically a mechanical design engineer. I've worked as a mechanical designer for many years. I have a project that I would like to talk about my experience in converting a MaxNC desktop mill from its original software hardware to a Gerbil controller with a Gerbil panel software for controlling the CNC mill. The maxnc tabletop miller is a tool I purchased to assist in the teaching a CAM program course that I taught from 1986 to 2008. And and this was for the engineering program that was over in Stratham at the Stratham Technical College and at the Pease Trade Board. When I originally got the miller, it was during the 90s when computers came with printer ports, which were required in using this CNC software. This picture right here illustrates the maxnc. Uh, this one cable coming out the side would go plug into a computer with a printer port or a laptop with a printer port. The software would be loaded on there. You'd run the software, and then you would load up G code onto the machine, and then you could literally uh, that this controller in the back would control the machine tool, move the axes where you wanted to. The spindle was controlled with an on-off switch with a potentiometer to give you various speeds and feeds. The primary purpose of the machine was for educational purposes, teaching the basic concepts of G-code programming, setting XYZ 0 points, showing cutter diameter offsets, as well as tool length offsets. I had researched on YouTube for videos for building CNC machines with Kerbal controllers and would suggest anybody who is interested in doing anything similar to this do the same thing, since use cases are different. Um, I com I purchased my components mainly from Amazon, and to be able to get to this, get to a point where I could take my components I purchased and put them on a machine, I ended up making 3D models. Now, the program I used was a uh, Libre design. I am a design expert here. And as I said, this is my home. This is my home system. When I work at the office, I use Siemens and UGNX CAD software. And when I taught, I used their AutoCAD products, and that went from Inventor to Mechanical Desktop to just the plain Jane AutoCAD software. But here, I reversed all the components, basically took measurements off the machine so I could reverse um, engineer it. And then I reverse engineered all the components, my components being the stepper motors, my, in a really basic uh, of the garble control box, and also limit switches. I put them in the position that they needed to be in, and then I designed 3D components, brackets, for holding these. Now, for some of these brackets, I built in mounting places for the limit switches. So if I take my table, move it back and forth, you can see where it hits on the side of the table, which would cause the limit switch to um, act out. Also for the y-axis, same thing. My components in here, such as this one limit switch, is for the y-axis. This is different than the others two, which are built into the motor mount, the stepper motor mounts. It's different because there was no good place to add it in the back because nothing comes back to touch it off. I created a Gerbil mounting plate on here so I could mount on the controller. Once I had designed all the components in CAD, which doing that design, plus I also designed this spindle motor mount. Once I designed all these components, I created the models by use of a 3D printing. Okay. Once I printed the 3D components, I went and created, I did an assembly with all the parts. And a lot of that parts was just doing troubleshooting of the physical devices. This is a picture of my CNC miller, and this is the garble controller. It has a homing function, which is important on these type of machines. Using anything garble, it's important that you use a homing switch, so it'll home down to this corner, top will home up here. This way the machine knows where A0 is set for the machine. I loaded up a program right here, which just does a dry run around the machine just for the warm-up exercise. The spindle itself is programmable. It goes from 0 to about 10,000. It can go to 10,000. I think I've only taken it up to maybe 2 or 3,000 at the most. I have some switches mounted on the side, which are controlled on here for pause, for stop, and emergency stop. The machine is actually going at a fairly decent speed, as fast as it went on the last time. But I wanted to kind of show off this conversion uh, project that I had done, and wanted to present it in this manner. I hope everybody has a good day, and I'll turn this off as soon as it finishes off this run.